So, Steve, with Saralon, they have very, very nice ink formulations, including copper inks and stretchable inks, and very broad portfolio. Experts in formulation. So,
Mhm.
we're gonna hear today again about some of their very interesting materials, and this time focusing on stretchable heaters and membrane switches. So, Steve,
Exactly.
when you're ready, please share your
Yes.
slides.
Uh,
Great.
yes. I think I hope everybody knows the company Saralon already. And over the last, yeah, almost 10 years, we've been working on developing, conductive inks for different types of application. The portfolio ranges from, let's say, a set for printed batteries and printed sensors and so forth. But over the last few years, we observed there's quite a demand for new kind of stretchable, flexible, conductive inks, but not only to print the printed circuit, but to print the entire application. And this is pretty much what my presentation is about today. So today I'd like to show you or introduce our latest solutions for these kind of complex applications. But before I go into the details, just have a quick look into, let's say, the market today and also the potential in the near future, in the next few years to come. So today we talk about stretchable electronic market volume is around $500 million, but it's expected by 2032 that it will grow up to 3.3 billion, which is an annual growth rate of around 23%, which is significant. And who are the drivers for that? So I would say mainly automotive and also 3D HMI application manufacturers, because nobody these days like to use any button, let's say, control panels anymore. So the trend goes towards three-dimensional, flexible control panels integrated into new design elements. And these are the main drivers for this kind of technology. And by saying that, as I said, Saralon was more or less eager to bring some ink sets, some compatible ink sets to the market to offer an entire solution for these kind of new, let's say, requirements. And let's start with the stretchable heater ink. So why you need stretchable heater? I mean, it's quite obvious. For example, when we talk about these new kind of electrical cars, there's quite a trend towards surface heating. And for example, when you take these things into account for the seat and the armrest, also these kind of heaters, they have to withstand some mechanical forces. So not only the substrate needs to be flexible, but also the inks for the heating. So this was pretty much the challenge when developing that. I will go to the details a bit later in that presentation. So the second thing is we also developed some stretchable EL display. You might wonder, why do I need that? It's pretty obvious, because these days when we talk about light, also driven a bit by the automotive industry, either exterior or interior, you want to have some surface illumination, let's say, in three-dimensional shapes that gives you plenty of options. And this is one of the drivers, but also for promotional items, wearables, and so on. And that's why we developed this kind of ink set. But last but not least, membrane switches. Membrane switches is already a hot topic. Saralon offers entire ink sets, either with some high silver content ink for the membrane switch today, for the standard one, or with some low-cost solution, either copper-based or low-cost silver one. But the next big thing is not some flat two-dimensional panels. The next big thing is three-dimensional things with thermoformed panels, applications. And that's why you need some stretchable, some flexible inks that can withstand this process. And that's why we developed this stretchable membrane switch inks. So by saying that, let's go into the details. Let's have a closer look into the stretch heater application. So what you see is it's basically, as I said, it's a compatible ink set that consists of three types of stretchable inks. So the base is our, the base is our Stretch Silver 100 ink with a stretchability level of 300. No, it's a bit delay here. Okay, so with a stretchability level of more than 300%, which is quite impressive, I would say, and a sheet resistance of around 30 milliohm per square. So followed by the stretch carbon. The stretch carbon is basically then the heat element, and it has also a stretch level of around 100%. but not the most